Okay, so circles are not gone, okay? The things you know about circles beforehand can get applied into this section, but we are going to learn a little bit more. This is called angle relationships in circles. So we already know about central angles. They would be the same as the angle that, or the arc they intersect. We already know about inscribed angles. They would be half the length of the arc they intercept, and we're going to learn about a couple more relationships today. The first is a tangent and a chord. So we often just call this the tangent chord theorem, but it is called the tangent and the intersected chord theorem. And it says if a tangent, which is the line on the outside only intersecting one point, and a chord, so end to end, this could be a diameter or this could be a chord, intersect at a point on the circle, that is the point of tangency, then the measure of each angle formed is 1/2 the measure of its intersected arc. So not any different really from an inscribed angle, except that it is not obviously both inside. So this arc on the right-hand side from A to B, half that would give you the value of angle 1. And then BCA or ACB, the other arc, half of that would give you angle 2. And then obviously vice versa. If I have angle 2, I could double it to get arc AB. So 2 times, well, let me write it underneath the one that it's on. 2 times the measure of angle 2 is going to give you the measure of arc BCA. And 2 times the measure of angle 1 would give you the measure of arc AB. So you can use this both ways.
Wait. I zoned out for 1 second.
There's the ignoring part, huh? All right, then comes the angles inside a circle. So we tend to refer to this as the floating angle. This is an angle that's formed, but it is not at the center. It is somewhere inside that circle. It's formed by 2 chords, but it is not on the center. If it was on the center, those would be central angles, and they would equal the arc that they intercept. These are these floating angles that are 2 chords intersected inside the circle. The measure of each angle is 1/2 the sum of the measures of the arc intercepted by that angle and its vertical angle. So if I was trying to find angle 1, it is 1/2 the sum of the arc it intercepts, which would be DC, plus the arc its vertical angle intercepts, which would be AB. So we add those 2 arcs, we divide by 2, basically.
So be DC plus AB
Divided by 2. Yep, so let's say this is 80 and this is 40. Angle 1 would be 1/2 of 160, and angle 1 would be 60 degrees. 120. 1/2 of 120, which is 60 degrees. Yes, thank you. Okay, and then angle 2, if I wanted to find the measure of angle 2, I would add what 2 arcs?
The same ones, AD, BC.
AD and BC.
Oh, what?
If I wanted to find angle 2, I add the arc it intercepts and the arc its vertical angle intercepts, and then divide by 2. Questions on that one? All right. And the last one has 3 scenarios, but it is an angle outside the circle. There are 3 ways to form this angle: a tangent and a secant. So if I have a tangent and a secant, which would be this last one, this is a tangent, this is a secant. If the angle formed by a tangent and a secant can be found by doing the arc on the opposite side. So we call this the big arc minus the little arc divided by 2. So a lot of times you'll see that. Big minus little divided by 2. And that equals an outside arc. Outside angle.
Where's the outside angle?
Like angle 1 would be the angle I'm trying to find here. So in this case, whatever the measurement of where x is would be that minus y divided by 2 would give you angle 1. The second scenario is 2 tangents, and that looks like your ice cream cone. But now we're not talking about the lengths of those sides. We're talking about the angle formed by that. So it's still the same thing. The big arc minus the little arc divided by 2. And the last one is 2 secants. So that would be the first one here in the diagram. And it's still the same thing. It's big arc minus little arc divided by 2. So you will see when you get given these examples, the first and the last one on this slide, like left and right, they have to give you 2 things. They can give you the big arc and the little arc and you're looking for the angle, or they could give you the big arc and the angle and you're looking for the little arc, or they can give you little arc and angle and you're looking for the big arc. But they have to give you 2 pieces of information or enough information to find those 2. For this middle one, it's a special case because those 2 arcs form your whole circle. So they only have to give you 1 piece of information. If I gave you that this was 100 degrees, what do we know about x? It's 260. So they only have to give you 1 of those, whereas the other 2, does that make sense? Whereas the other 2 have to give you 2 pieces of information. Because the 2 tangents, the arcs form, is your entire circle. Whereas in the other ones, it's only part. Like this and this are the only parts you're given. You're not given the outside ones. Okay, does that make sense? Yeah, okay. All right. A circumscribed angle is an angle whose, an angle whose sides are tangent to the circle. So that's the one we're just talking about, okay? That ice cream cone angle, the bottom of the cone, is called a circumscribed angle. Ice cream cone, yep. The bottom part of that best part of the cone, that's called your circumscribed angle. Yes, it is. And the circumscribed angle theorem. All right, the measure of the circumscribed angle is equal to 180 minus the measure of the central angle that intercepts the arc. So the angle on the outside, that bottom of the cone angle or the circumscribed angle, is equal to 180 minus this angle, okay? And it comes from what we just talked about. If I knew this angle, I would know this arc, right? It would be the same. So let's say that this is 100. That arc would be 100. The angle the other arc would be 260, and then it would be 260 minus 100 divided by 2. So the shortcut is if you know this central angle, and it only works if you know that central angle, then you do 180 minus the little arc, minus the other way around. 180 minus this gives you the angle. 180 minus the central angle.
Can A and B like be placed anywhere?
Sure.
And it'll still be minus 180?
Yep.
Good job.
Well, but not on the, yes, on, it has to be the minor arc though. Like you can't put B over here because it wouldn't be the tangent anymore. Does that make sense?
Oh, so that
it only works with the 2.
So it can be anywhere. They have to be on tangent.
You have to be able to make it, so if I move it around, if I like put A here, yes, Gabriel, go. If I put A here and B here, then I could go here. Yes, as long as those are the 2 tangents.
They all
Yes,
have
is that
to
what
be
you mean?
tangent.
Yeah. They have to be the points of tangency.
Wait, why you say never mind? Wouldn't the arc and angle length be the same?
Right, but the shortcut is if you're given the angle.
Or would it be the same thing?
It would be, but you wouldn't be given the arc. You would be given the angle to use the shortcut. Yes, they're the same, but it's one less step, right? Okay.
Hey, you have to prove it this.
All right. So they're going to be like not always just what you need. It's going to have like a lot of stuff going on like this. When you see something like this in the homework, this is where you're definitely going to need to either screenshot that picture or copy it over and draw on it. Okay. Get comfortable starting to draw on these things. So example 1 says UT is tangent to the circle. So this segment here is tangent to the circle. Okay. Which means what? Yeah. So it would intersect the radius or the diameter at a 90-degree angle, not necessarily a chord.
Doesn't look tangent.
Okay? It kind of doesn't. You're right, but we're going to say that it is. All right. Then you need to find arc WT. So arc WT is here. And the only measurement I'm given on this is the angle. And then I'm given the arc here. So in this scenario, I would say this is when I start drawing the sides of the angle. So if you want to draw the sides of the angle, they would look like this and they would look like this. That is a tangent and a secant. So this is my big arc minus little arc divided by 2 equals the outside angle. So what's the big arc? 100.
So what's the question? It says UT is tangent to the circle.
Yeah.
Thank you. What else do I have?
A, find the measure of arc. Oh, I'm so sorry. Find the measure. I missed the words find.
Oh, you want us to do everything?
Correct. The measure of arc UT. So do I have the little arc? No, that's what I'm missing. So this is what I'm trying to find, right? Divided by 2 equals, do I have the outside angle? Yeah, 30 degrees. So then to solve for x, I'm going to multiply by 2. 100 minus x equals 60. Subtract the 100. Negative x equals negative 40. So x equals 40. All right, go to the next one. The next one says find the angle U or TVS. TVS is what kind of angle?
Oh, it's the circumscribed angle theorem that we have to do.
What did we call it shorthand? Jonathan.
I don't remember. I just know we have to do.
Sophia. When Gabriel comes back.
This one's
This is the floating angle, okay, right? It's not in the center. It's not on the side. So it is the arc in intercepts plus the arc its vertical angle intercepts divided by 2. 210 divided by 2, or 105. Good so far?
Yes.
Okay, I'm going to add on here what we found. This was 40. This is 105. Okay, then the measure of angle RVS. RVS is this angle here, which is, again, one of those floating angles. It is equal to the sum of the two angles, the arc it intercepts, right, which would be unknown right now, plus the arc its vertical angle intercepts, divided by 2. I know the vertical angle. I don't have RS. How can I find it?
The length of the other arc, subtract from 1.
Good. So I got 110, 140, or 250 if I add up the other 3. Subtract it from 360. And now I have that angle, that arc too. So to find angle RVS, I add 110 plus 40 and divide by 2. 75 degrees. Yep. Oh, that's it. Yeah, sorry, no, keep going.
So RVS is a floater.
RVS would be a floating angle, yeah. You'll know if it's the center, if it has a like solid dot, or if it in the direction says circle V. Then you would know it was the center. All right, and then we already found arc RS. It is 110, and it's 110 degrees, because there are degrees, and then there's length, which is a different kind of measurement. Questions on those?
No.
All right. Question 2. If the measure of arc AB is 105, so here's my 105, then the measure of angle D is what? This is your exterior angle with 2 tangents. So it would be big arc, let me do that in a different color, big arc minus little arc divided by 2. What's the big arc?
355.
I would do 360 minus 105, that's 255. So it's 255 minus 105 divided by 2. 150 divided by 2, 75. All right. Again, another exterior angle, right? But this time it's 2 secant, so big minus little divided by 2, and I needed 2 of the 3, which is what they gave me. So the big arc is AB. That minus the small arc it intercepts, which is 20, divided by 2 equals the outside angle, which they also gave you. That's 10. And then I want to solve for the big arc. So multiply by 2, x minus 20 equals 20, and add the 20, and x is 40.
That's pretty easy.
Yep. I want to stress that these are not necessarily drawn to scale, so obviously that does not look like it's 40 degrees, okay? They are not drawn to scale, but the relationship of those angles should make sense. 40, because it is the bigger arc, should be bigger than 20. So keep that in mind. If you like end up working it out backwards and you get something that's weird, make sure it makes sense.
This one, the next one's pretty easy.
Oh, good. Questions on this one? Okay, last one. What do we do here?
Just 180 minus 135.
Good. This is our shortcut because that's the exterior and this is your circumscribed angle and this is your central angle. So 180 minus 135 gives you
You said 45.
45. Now, if you didn't remember that theorem, you'd go all the way through. I would say if that's 135, then so is the arc it intercepts because that's a central angle. And then I would do 360 minus 135. And I'd get 225 for the big arc. And then it would be 225 minus 135 divided by 2, 90 divided by 2, which is 45. But obviously that shortcut is a shortcut for a reason. Saves you a lot of time. Questions? So three overall theorems for really with a shortcut. The angle formed by a tangent and a secant, either the two tangents, the two secants, or the secant and the tangent, that's the big minus little divided by 2, and then the floating angle, and then the shortcut, if you're given the central angle and a circumscribed angle. All right, homework is on big ideas already. You can get that open.